So hi everyone, and thank you very much for the opportunity to come and present. I was absolutely delighted when I got a call last week saying would I give a talk, and then probably pretty terrified because of the topic really took me back to my roots, where I started many years ago in mineral processing, and it's really exciting to see that my very first boss when I was 18 years old is online. So I hope I don't embarrass him as I might have done when I worked for him many years ago. So I thought really what I wanted to do this evening and this morning is just take a little bit of a strategic view of mineral processing. And I think what has been really interesting as I've transitioned from an industry role into the academic role at the University of Queensland, managing a research institute that is put together to really tackle global challenges and to have a look at the sustainability of the mineral sector, that we really are working in an unbelievably dynamic and changing world. And I suppose my opening comment is a bit of a challenge to all those online. If I have a look at the work we've done as an institute over the last 50 years, it's really been focused on, so how do we make mining sustainable? If I look at the questions we've been asked over the last 4 years, it's been a lot more philosophic of, so what is mining's role in global sustainability? And I suppose what I would like to do in the presentation is just give you a little bit of background of UQ and particularly of the Sustainable Minerals Institute and the activities that we've undertaken. But I suppose just always come back to the question of, are we really answering the question of what is mineral processing's role in achieving a sustainable world? Now, it's interesting to see over the last number of years how companies' purpose statements have shifted quite dramatically. And I noticed there are a number of companies represented this evening, a number of the mining companies, and you may well reflect on some of these purpose statements. They generally have, what is the role of a mining company in improving lives? They'll have something around building a better future. And then, of course, the one that I knew very well was reimagining mining for a better world. So, and then the other one, what we're seeing is society's expectations of companies, of mining companies, is changing dramatically. And it's becoming a lot more vocal and a lot more connected into absolutely everything that's going on. So we're living in a very complex and dynamic world. And the question is, as a mineral processor, what can we do to have an impact? I would like to acknowledge a number of people on the presentation because being the director of the Institute, I get to pick slides out of everybody else's presentations that they've given over the last number of years. And I've just taken a few just to build up a bit of a case study and just to give you a flavor of the kind of work we're doing, but more importantly, the approach and the philosophy that we're taking to all the research that we do. So that's the introduction. I thought what I might do as well is just a little bit about UQ. For those that don't know, we're in Brisbane, and that's in Australia, an absolutely fantastic part of the world. The university is incredibly proud of our top 50 status, and we work very hard to maintain that across all of the different rankings, which really look at research excellence. We're structured around the normal faculty structures, but then of course we've got our research intensive institutes, of which the Sustainable Minerals Institute is one of them, and our focus is on resources. And then of course we've got 2 commercialization companies that take the IP that we generate and turn that into impact through either spin-off companies or products or sales. And one of those companies is the JK Tech, and I'm the managing director of that, and it's been incredibly successful at taking many years, over 50 years of mineral processing research through the Amira projects and through other projects and turning those into software and tools and products. So I wouldn't mind just saying a little bit about that because it's a really interesting model of how we can bridge that interface between curiosity-led research and challenge-led research and making sure that we're having an impact. There's nothing more depressing than writing a report and it ends up on a shelf. We're really particularly excited about seeing the change in the operations and making sure that what we're doing is adding value. So in terms of that, the university's commercialization arm has been incredibly successful at commercializing a lot of our medical research. And we've had a number of very successful companies spun off over the years, and that money has been able to be reinvested back in research. And at the moment, we're incredibly proud of the COVID-19 vaccine that's been developed and is through into the final stages of trials, and is ready to be mass produced. So very, very excited about that and holding thumbs, because I'm incredibly frustrated at not being able to get out and visit people around the world and get onto mine sites. Right, just in terms of the Institute, I thought just for a bit of orientation, we built up of 6 discipline-specific research centres. These centres have a history of the industry coming to the university and saying, well, we think that there's an issue that needs to be tackled, for example, in health and safety, and could you please go and have a look at that and build up some expertise? And people, for example, in health and safety, be aware of the risk management work we've done and the collaboration around the world with universities in all regions to roll out a risk management approach that comes out of the nuclear industry. We have a centre that looks at social responsibility in mining, and at the moment, they're incredibly busy engaging with companies to help them think through social performance as a function. And essentially, a lot of the research we do will come and will start from a nexus that is the people centres. It'll start from social performance, what do we think the expectations will be, and then work our way back into technical solutions. Whereas often what we've seen in the past is we have a very good, elegant technical solution, and then we try and persuade people that this is going to be acceptable. We then have 2 centres that really focus on environmental issues, both water management, and they've put out a number of standards around water management, and then, of course, the Centre for Mine Land Rehabilitation, which really looks at rehabilitating mines. And at the moment, I think what we're seeing is quite a number of mines coming to end of life, and there are big questions around closure, around what would the economics, what will the social impact of those closures be, and we've managed to get a research centre up looking at those aspects of closure. And that's a $100 million centre with a number of collaborators, and it's in collaboration with University of Western Australia and funded by the Australian Commonwealth. We then have the centres that we're really going to focus on today, and that's really our production centres. So the world famous JKMRC, and then the Bryan Research Centre. And in those centres, essentially where we do the work that spans from mining, geology, and mineral processing, and looking at how we treat that as an integrated system. I'm still unbelievably amazed at the number of operations that are horribly siloed, and I probably will pick up on this a little bit more, and the number of mineral processors that don't have a fundamental understanding of their ore body. And even if you are doing process control optimization, understanding that ore body is critical. And in many ways, I didn't get to post my thing, but that's something I would be pushing, is make sure you've got really good characterization of that ore body in your optimization strategies. All right, and then what we've done over the last 4 years is we said we're incredibly good at all of these different disciplinary strengths, and we have a really proud history. But what we haven't been doing is bringing that all together and developing these multi or transdisciplinary teams to tackle what we thought would be the global challenges facing the industry. And we believe, and we firmly believe, that you can only solve these global challenges if you have multidisciplinary teams. And that's what we've done. So we went out to the industry, we interviewed, I can't remember now, it was probably my first year, I probably interviewed about 50 CEOs around the world and said, so what keeps you awake at night? What are the big challenges that you're looking at? And those are the programs at the bottom. So unlocking complex ore bodies, where we're going to get the metal for a low carbon future, where we're going to get the metal for moving into electrification, what are the challenges around that? And we found some really interesting outcomes from that, and very unexpected for me, probably not unexpected for many other people, but I'd like to touch on that a little bit later. We then got governance and leadership, and this really came out of a number of countries asking us to have a look at the governance structures around the resources sector, particularly as they were seeing an increase in a boom and they wanted this to be done responsibly. And coupled to that was, so how as leaders can we influence such that we get better environmental and social outcomes as well as economic outcomes. Transformational learning is very much around the future workforce, and also how do we do tech transfer? How do we get the great knowledge that's been generated and make sure that it's imparted and taken up sustainably? Digital mining, well, that's definitely the flavor of the month, and what we wanted to have a look there was maybe at some of the topics that are forgotten. So what are the social impacts of automation? what is the impact on the workforce? What is the impact on health and safety when you have a hybrid, automated human interface systems? What about those human factors? And then we had one that looked at transforming the mine life cycles, and that became the Collaborative Research Centre. And we've just kicked off a new one around development minerals. And this really came out of a realization that the development minerals sector is probably an order of magnitude bigger than the traditional metals sector. And there's huge social, environmental, and societal issues that can be addressed, and we can use our skill set in that space. What we've also done, we were very, very fortunate and very grateful to the Chilean government because they funded us building a centre of excellence in Chile. And the main focus there was to build the strong networks into the academia in Chile and work with all the universities there to collaborate and to tackle the great challenges, but then also to interface into the sector. So that's the institute. We've got a number of disciplinary depths, and we bring that all together on the strategic programs. The three that are coloured in are what we call the production centres, and they work as an integrated team across the mineral processing, mining, and geology space. Just quickly, in terms of our model, we have a very simple business model. We are fully funded by the sector. So we do professional development. Often this leads us to doing some consulting work where people are going, well, that's really interesting. Could you come and have a look at this problem? What we find is often when we look at the problem and we unpack it, there's some knowledge gaps, and that really helps us fund research, particularly if we can get some really bright young student that's finishing up and would like to do a postgrad course, and they can come in and focus on that research. That's really great. And then we produce tools, software, and products because we want to be able to give something that the industry can take and adopt and use. And many of you will be aware of the JK, SimMet, SimFloat, and the characterization tools, the MLA, Mineral Liberation Analyzer that we developed, and those tools. So that's really the model. And what we find is when we get this all working together, we begin to have an impact, and we begin to add value. And then, of course, right at the middle, we never want to lose focus that we're here to develop people, and we're here to develop leaders. So everything we do is centered around developing people. So just quickly, in terms of the production centres, it's a significant undertaking. It's got close on 50 staff, and we're very fortunate to be recruiting and growing at the moment because there's a number of great collaborative projects that have been kicked off. We probably have 20 to 30 different nationalities at the centre at any one time, and a very good gender balance. Our target is 50%, and we're pretty close to achieving that, and that's across all levels and work types. And then, of course, as I said, we're funded by industry, and that's really critical to us. At the bottom, just try to pick up some of the research themes that we're working on, and you'll notice it spans across geology. We're very, very strong on characterization, and then using that characterization in building semi-empirical physics models that are validated. And I'm amazed at how many models aren't validated, and people are making decisions where the model doesn't work. Because they've assumed it's linear when it's not. So if you want my process control one, please just validate your models, do the experiments. It's really important. And then, of course, Mohsen, who's online today, is leading our process control data analytics work. And what we're hoping to do is build those physics models into advanced model predictive control. And we're having quite a lot of success in that space. And you probably would have done better to get Mohsen to talk on that. And maybe that's something we could look at we're doing in the future. And then, of course, we're doing a lot of work at how do we reduce the footprint, and that's the sustainability work of how do we make mining sustainable. All right, in terms of the centre, we've grouped around thematic areas. I've spoken about Mohsen's advanced process control, and Marcin is looking at energy, and I'll use one of his slides that he put together for me later. Kim Rungi's doing a fantastic job in separation and looking at novel separations, and I'll touch on some of that. And then we've recently added a high temperature processing team, which is, I'd like to think, the world champions in building thermodynamic models for complex mineral and complex metal processes, polymetallic smelting, which from my previous life is incredibly important and useful. And then, of course, we've got the standard tools that I think you'll see with any world-class mineral processing group in terms of being able to pilot plant, characterize, and do the test work we do. And as I said, I'll pick up on some of the programs. I notice a number of those online are part of these programs, and we really, really appreciate your support. In terms of geology, generally the mining geology piece are separated out and treated as separate entities. We see them as being integral. and we're busy doing a number of work across that in terms of from exploration through to environmental geochemistry, and basically the geometallurgy space, mine to mill. Those are all things that are deeply entrenched in our DNA. What we are seeing is a big shift into new economy minerals, and doing quite a lot of work across Queensland to have a look at what's there. And all the time, what we're trying to do is produce these predictive models and these predictive tools that can de-risk projects up front. This we put together just as a snapshot in terms of how these three function together. And it's been incredibly successful over many years, incredibly proud. At the moment, we're busy doing a rebuild. If you look at the years of experience, we've got a really young team there now. We've managed to attract quite a lot of early career researchers. And then we have some really old experienced people that are able to guide some of that work. We've probably got 35 plus years of industry experience in a number of people on average. All right, and then the other one that's been really interesting for us is COVID has really forced us to go online, and we've been running seminars and pro courses over the last year. And if you had said we would reach over 12,000 people this year, at the beginning of the year pre-COVID, I would have said forget it. We probably would only get to about 1,000. We've well over 12,000 hits in terms of our seminars, and I'd encourage people, if you are looking for content, it is there, it's online, there's YouTube recordings of those seminars, and it's across the institute. And then, of course, the other one was we're very, very proud of our books. So what we try to do is put together leading practice and then publish it, and these are openly available, and they carry the mineral comminution circuits. I think my first boss gave me that one and told me I should read that to understand comminution. And then, of course, the metal accounting and reconciliation, I think, is a particularly useful book if you're having a look at guidelines, which I gather is part of your mandate. So welcome to have a look at those. The statistical methods, I think, is also another very important one, and I'd probably recommend that if one is having a look at process control. All right, so I just wanted to do a time check. Dominica, how much time have I got left?
We have about 10 minutes.
All right, then I'm bang on time, so that's fantastic. Thank you for that. All right, so what I thought I would do is just step through this program that we put together. And what we did is we put together these strategic programs, and we went out to industry and said, would you please support us? And we got support from the university. And we asked a very simple question, where are we going to get the supply of the future? The data is saying us that the new discoveries and recycling, they just were not going to be able to produce enough metal for what was being forecast. And the question was, so why are these ore bodies not coming on? And the mineral processors and geologists and mining engineers all went, well, because of the economics and because they're incredibly complex to process. And I, from my previous role, remember a number of ore bodies that were really interesting, but had severe technical challenges that were holding them back. So we went on to the S&P database. We pulled out all the ore bodies that were known, registered, and hadn't been developed over the last number of years. And what we found is there's probably, in copper, there's probably about 50 years worth of copper supply known, economic, and can be exploited economically right now. And we know how to do that. 75% of those were being held back because of social, environmental, and governance risks. So suddenly, our Centre for Social Performance became really critical in trying to understand, so why were these ore bodies not coming forward? And we've written a number of papers that now have gone out and looked at this from a multi-transdisciplinary point of view to try and understand what the challenges are with those ore bodies. And then based on that information, we've then gone backwards now and said, all right, so what technical work do we need to do? And out of that has come our research programs in the mineral processing space. And there's no surprise, a number of companies are looking at those, a number of researchers are looking at those, and we're basically trying to build an integrated approach to try and unlock what we believe are going to be the metals needed for the future. So in terms of that, these are just some of the project themes. I won't go through them. There may be some that are interesting there. For example, understanding the mine closure as key aspects to social performance. So a number of executives said if we can't close mines well, we won't be able to open new mines. And I think we're seeing that coming through. Water in certain areas becomes a big issue. There are deleterious elements that need to be had a look at. particularly, for example, arsenic in copper concentrates. And really what we've done now is put a program of work together to try and address and get some information around these programs. And this is just what we've done. We're up to about $7.6 million from industry. The programs are focused. So what we're trying to do is bring a cluster of companies together whereby the individual companies can have very targeted work. And then out of the targeted work, we can share generic studies across the companies. So we don't end up with a dilution of the lowest common denominator, but we end up with a collaborative approach whereby everyone can be quite specific as to what they're looking for, but we can then mold it into what can move the dial and create change. And then the other one is what we've tried really hard is to work across multiple disciplines, across UQ, but also across universities around the world, where we believe they have the expertise that's required to unlock the problem. I think nobody can be so arrogant to believe that they can do everything. So what we're trying to do is connect into the best in the ecosystem and bring people together and build these collaborative networks. There's just a couple of pictures of everybody that's been working on the programs in the last 4 years. And every time I see a picture like this, I sort of have to pause for a second. It's just fantastic to have this amount of talent all focused in on these grand challenges. And there's some of the companies that have very kindly sponsored the work, and I hope are getting value from their sponsorship. All right, so I thought it is about mineral processing, and I thought maybe what I would do is just pick up on two of the collaborative projects that we're running at the moment. And once again, these run that model where companies come forward with specific questions, and then what we try to do is cluster it around different themes so that the companies can share the information as they see fit. The one is around ore body knowledge, and here once again you'll see a mix of mining engineers, metallurgists, mineral processors, environmental scientists, and what we're trying to do is build up really good ore body knowledge across the entire value chain. And then that becomes the basis for us to be able to model and understand and de-risk projects. And once again, what we're trying to do is a lot of the mineral characterization tools are typically expensive and laborious. And what we're trying to do is find ways to be able to build better, quicker, cheaper, faster techniques whereby you can do more characterization at a lower cost. And once again, remove that impediment to collecting lots of data and of high quality. And then once again, understand and predict that from a geological basis and then all the way through into the final, for example, tailings or disposal. Lots of work has often been done on the value minerals and very little is being done on waste and understanding how one can treat waste separately and create value from waste. And once again, this is just very much, I just really felt I needed to emphasize how important it is to get these geological, mineralogical characteristics done. My experience is this is incredibly valuable. And my very, very first task was spending many hours looking at mineralogical data to try and understand what it meant from a mineral processing point of view. And this should really be part of the DNA of all mineral processes. Okay, so just want to pick up the last two projects. So this one I'm very, very excited by. And it's again, it's almost old technology. It's been around for a long time, high voltage pulse. The original work was done and the focus was on how do we replace conventional comminution, and what it required was putting in an extreme amount of energy. And yes, it worked, but it wasn't fantastic. And then Frank Shee noticed that actually if you put in a very, very small amount of energy, just enough to break, what happened was you got very selective breakage. And I believe this technology will unlock all the grade engineering, the selective separation by size. It's probably the most exciting technology I've seen for differential breakage. And if we can overcome the engineering challenges and get it to be a continuous process, I believe this with blasting, with screening, and with conventional sorting, you could probably eliminate a huge amount of waste before it even hits the mineral processing plant. So we've got a consortium working on this. Anybody's interested, please let me know. It's actually starting to look pretty good, and I'm hoping, my expectation is within the next 5 years, we'll be piloting this at scale in a continuous process. The other one is processing of coarse particles, and I know a lot of companies that have a look at this, and for me, this one is really around being able to float those really coarse composite particles. And then the other one is, of course, leaving any of the sulfidic material locked in silicates if it doesn't get recovered, such that to reduce the AMD process. I think there's a lot of work that needs to be done in understanding this, and we've got a consortium working on it and trying to understand how we can model it so that it can fit in our normal approach, whereby we can give companies certainty of where this would work best in their circuits by doing standard characterization up front. So developing the characterization, developing the models, and being able to predict where this would add the best value, and thereby being able to optimize that process further. And then this one, I know Mohsen's online, and his team has been looking very much around classification. And I think this has been a nut that's been really difficult to crack. And if we can get better classification and not overgrind, once again, you start to enhance that coarse particle flotation. You then start to improve your downstream processing and disposal. So this was just a very quick example that Mohsen put together for me for a presentation for a number of years ago. It was for a large copper operation that was having a look at how they would deal with a large amount of waste. And of course, the realization that we're not going to be able to build wet tailings dams going into the future, given the recent events. And one's going to have to move to dry stack tailing filtration. And the cost barrier there, of course, the finer you go, the more expensive that becomes. So if you can end up with a very coarse grind, and we work backwards from trying to get the filtration and dry stack tailings costs down to normally $1 a ton, and then work back to the front end of the circuit, what would the grind have to be up front, and what impact would that have on recovery? So we did a quick sort of desktop study. The numbers I don't think are far out, and I think something like this is very doable. And really what we've got now is a couple of PhD students working through this to actually get the numbers better. And then as the models are developed in those various collaborative projects, we'll be able to focus in on this and be able to give much better design criteria and design thinking on how to do this. Very, very exciting space whereby we can start to address a number of those societal concerns and yet not lose the economic benefits and the economic recovery of metal. So I suppose this is a quote from Rick, which I thought was really important. And what I've learned in the last 4 years is universities have unbelievable untapped potential. And the company that can work out how to access that and to get that potential working across silos, not only within the university space, but also within their companies, is going to benefit hugely. I saw a paper that's saying there was 20 to 30% benefits just in the supply chain, and that excludes the fundamental work that we can do to improve the process. So I think I'll leave it there and just to say thank you very much for the opportunity. My challenge to you is, so what is the role of mineral processes in making the world sustainable? We really need to rethink our purpose. Thank you, and I'm happy to take questions.
Thank you, Neville. Thank you so much for your presentation today. We actually have a few questions here on the chat, so let me go quickly through them. I think Vanessa Nava will contact you directly as she was having some questions about projects and programs. Here we have a question from Osvaldo. What are we doing to change the way we mine? Should we be more careful on large amount of water and energy that we use? Large amount of tailings. In Chile, we have earthquakes. This is the next disaster coming. No space for tails to be deposited. No water, no energy. What are we doing to change these old processes?
So I think there's a lot of work that's been done, and I'd like to really endorse it. I think the philosophy has to be, don't mine as much waste. So when we have a look at the process, if you're wanting to improve all of your efficiencies, leave the waste where it is. And then if you have to mine that waste because it's a bulk process, try and be selective in how you separate out that waste as early as possible. CLC ore was put together. It came out of the Institute many years ago, and they've done a lot of work in thinking through this concept of grade engineering and basically looking at how can you take from the mine planning, from the block model, and how can you model that all the way through the process such that you eliminate waste as soon as possible. So I always had a very simple phrase. I said we need to do selective blasting, where you try and blast the value into a fine fraction. That's incredibly useful for precious metals. Once you've got it into the fine fraction, try and screen out as much waste as possible. And then after that, then have a look at a sorting strategy. Multiple companies have had goes at different aspects. What I haven't seen is a very integrated approach that says, I understand my mineralogy, I understand the deportment, and therefore I'm going to design each of those different phases of separation. And I think it's because flotation is an incredibly successful upgrading technique. It's robust and it works. And therefore, we've been quite lazy in trying to tackle the problem up front. So this is where I think absolutely I agree with the comments. I think Chile's got a huge opportunity to really think through the whole mine to mill concept. I know there's some brilliant case studies, but I mean, anybody that's not achieving a 20 to 30% improvement in productivity by doing a mine to mill study, give us a call. We'd love to work with you. I can almost guarantee it. It's every single site we've been to, just by getting that integrated thinking working and doing some really clever stuff up front in the mining space, you can make huge impact downstream. There's great documents on it. Most of it's focused on increased powder factor, gives you better fragmentation, which helps the shovel, which gets you better throughput through the mill. But I think we can be a lot more selective and a lot smarter about it. And when I look at all the sensors that are being developed, I tell you what, it's just incredible. I think there's some really fun things we can do.
Terrific. Thank you, Neville. Here, Paul Shelley just added a comment to invite you to take a look to a CEEC organization that is also focused on these topics. We have another question from Vanessa. Have the research center work on TA and B concentrates any research or project?
So I'm going to try and have a look at that chat because I'm not actually sure what that means. I know Mosen's online. He's a lot smarter than me, so he might know what that is. Maybe if I could just get a bit more information, I could have a go at it, but I'm just trying to find the question.
I think Nev is more around the rare earth element processing.
Oh. Yeah, so at the moment, we're getting more and more demand to have a look at rare earths, and we are looking at that, particularly from an exploration point of view. In terms of the separation, I could probably put you in contact with a number of universities around the world that have done more work in that space. Our hydrometallurgy group, which isn't part of the institute, but it's part of UQ, has done a lot of work with that and has some patented technology in the battery space. So maybe if you want to drop me a line, I can connect you with some people, and I'm very happy to do that.
Perfect, thank you. I'm just gonna run through the last question just to be mindful of time. And those other questions that are pending, I will be sending those to Neville if it's okay with you, and then we will be sharing the answers. So JK Tech is the lead of technology about mineral processing. Is there any research about AI applications to mining? If yes, how can I examine these researches? Can you give us a web address?
All right, so JK Tech's easy. If you type it into your web browser, it'll pop up, and hopefully it's looking all very nice and purple because we've done a full rebranding, and we'd love to have a chat with you. But to be honest, the person I would connect with straight away is Mosen, who's online. And if you're welcome to drop me an email, it's just n.plint@uq.edu.au. And Mosen, that's exactly what he's doing. We've built quite a large capability around data analytics, artificial intelligence, and what we're wanting to do, and Mosen, please correct me here, what we're wanting to do is we want to take the physics-based models we've got, and we want to use the knowledge we've got from that to build it into process control systems and have much better predictive models that can work across a wider range of data. One of the limitations of the big data approaches on mineral processing plants is generally the plant operates over a very, very narrow window. I don't know of many plant managers in my career that would let you step even their ball mill across a whole range so that you could get all the data you needed for a proper big data approach. So what we want to be able to do is build those models that enable us to do that. So we've got a lot of work going on in that space. It's incredibly exciting. So please, reach out to Mosen. He can take you through the projects we're doing there. And we're looking for students that are really good at data analytics. Always looking for students.
Okay, looks like there's just one last question, and then we're actually, there was an entire conversation ongoing, so I thought there were more questions, which is great to have that much engagement. So I will just go through the last question. It is how you are leveraging the cloud to implement your ideas. So basically, how are you using the cloud?
So once again, here, what we've done is we've been collaborating with CRC Ore, and they've built a cloud-based backbone, and it's called IS. And essentially, that backbone we'll plug our models into, almost like you can buy an app and you can plug it into the backbone. And that is using cloud computing. What we're going to be doing is pretty much continuing to build those models and being able to plug that into any backbone. And of course, cloud computing is absolutely critical for being able to allow people to work on the same data set or the same solution anywhere in the world. Once again, I'm probably not technically able to comment on cloud computing. And it's, once again, I think Mohsen would absolutely be able to help you there with that. One of the great things about being at UQ is we have an unbelievable IT department and almost infinite computing power. So it's great, the things that we can do. So it's something that I think hasn't necessarily been fully tapped by the sector, is how they connect in and use these other great infrastructures.